Back to the part 2. Let's see some image formation by spherical mirror. Okay, let's take fifth gear here. So we are not gonna analyze each and every single cases like placed at infinity, object placed between infinity and C. Let's go like a revised version of that. Okay, first let us say it is placed at infinity. Okay, when it is placed at infinity, the image will be formed at focus. Okay, when object is placed at infinity, image will be formed at focus. So when the object is placed beyond infinity and center of curvature C, somewhere around here, the image will be formed at between C and F. Between C and F. Fine. So similarly, when image is at C, it will be inverted. When the object is at C, it will be inverted and of same height. Okay, this will be diminished. Okay, and when the object is placed in between C and F, okay, so image will be formed between infinity and C, and the object will be in increased size. The more and more closer it goes near the concave, more and more size will increase. Fine. This is the revised version of 6 cases of image formation by concave mirror. When object travels from infinity to the pole, image will also move from infinity to the pole, but in the negative direction. Okay, fine. So we need to learn something which is mirror formula. So what is a mirror formula? It's 1 by F is equal to 1 by V plus 1 by U. This is mirror formula where V is image distance, where U is object distance, and F is the focal length. Okay, let's come back to the questions later on. Let's see all the things which we need to understand and learn. Fine, let's go for transverse magnification. So transverse magnification is nothing but the magnification formula, which is height of image by height of object, hi by ho, right? Fine. So the magnification is hi by ho, which will be equal to V by U. Okay, which will be equal to V by U. Take the sign. We need to take the sign VU HIHO according to the sign convention. Remember, we need to take the sign according to the sign convention for these quantities. Fine. Let's move further, which is third one, longitudinal magnification. What is longitudinal magnification? In the beforehand, we have seen, like, if there is an image like this, it will be appearing like this or like this. Fine. Enlarging this length is known as transverse magnification, while enlarging this length, if there is an object kept here, enlarging this length or diminishing this length will be known as longitudinal magnification. Just in case there is a concave mirror, okay, there is object, one corner is A, another corner is B, okay, and let's say this is du, okay, and the distance between this and this is u, we all know that, right? So at v distance here, there will be an image formed which will be like this. It will be b dash, this will be a dash, right? Since it is inverted, it will be like that. So this will be du, fine, du dash, fine. So this is what, sorry, this will be, let's take as, instead of du dash, it will be dv. That is more understandable. Okay, now we write this as dv by, see, we wrote here as height of image by height of object, right? So similarly, the length of object, length of image by length of object, it can be also written as v2 minus v1 divided by u2 minus u1. Okay, so what are these quantities? Okay, so let's take this as an image, this as an image, okay, sorry, this as an object, separate object, and this as an separate object. And if we calculate the distance of this object's image, it will appear to be different, and this object's the image will appear different. So if we apply in this formula, we will end up in this. That's what it's mentioned here, nothing else. It's not a rocket science, right? So let's go for this formula. 1 by f is equal to 1 by u plus 1 by v plus both are same. Let's try to differentiate this. So this is a constant, so it will become 0. 1 by v dv, and it will become square, and minus will come, okay, minus 1 by u square du, fine. Now we need to find dv by du is equal to minus v square by u square, okay. This we have seen somewhere else, right? Which is magnification whole square will be the longitudinal magnification, right? Okay, fine. Let's go for superficial magnification. Superficial magnification. So every distance measured from the pole, right? There is something which we have learned, right? Every distance is measured from the pole. Don't forget that in previous cases, this u distance is measured from the pole, this v distance is measured from the pole. So every distance should be measured from the pole. This is an important note. Let's go for superficial magnification. What does it mean? Is simply, if there is something with h naught height and width w naught, it will be formed as, the image will be formed something like h of image w naught, okay. It is based on the area, okay. So superficial magnification is equal to area of image by area of object hi w naught. What is the area? Wait. Sorry. Okay. So what is the area of image? Length into breadth, right? So similarly, h naught w naught. Simple. And ms is equal to hi by h naught. When we separate this, it will come something like w naught, right? I. Okay. This will be equal to what? Hi by m, right? Okay. What is wi w1? Wi by w naught? It's also considers as magnification, right? It's also a length. Fine. I can take it m square. So superficial magnification is equal to m square. Fine. Let's solve some couple of questions so that you get a better understanding in this. So question number 1. Find the position and character of the image for a concave mirror. Find the position and the character or characteristics of an image of a concave mirror of focal length 10 centimeter. Okay. When object is placed at 30 centimeter, second at what can I give, 15 centimeter. Okay. So we have given a couple of informations and we have said to find the value. We need to find position and characteristics of image. Fine. So like we need not to draw the ray diagram, those all stuffs in this question. Just like analyze the values, that's more than enough. Okay. U is equal to let us draw. I mean, it's not so tough. It's placed in front of concave mirror, right? So I placed 30 centimeter. Okay. So focal length is somewhere here. This is 10 centimeter object. Fine. So incident ray will go like this, and the image will always be measured from the pole, which I said before. So image will be minus 30. Agree? Minus 30, and focus will be negative as well, minus 10 centimeter. Okay. So what we need to find? The position of the image, right? 1 by f is equal to 1 by v plus 1 by u, which is minus 30 minus 10, right? So 1 by 10 minus plus 1 by 30 is equal to 1 by v. Okay. So of course this is the correct method. Okay, let me find the value, find the answer, and then show you a shortcut. It's going to be minus 30. Wait, let me tell you the shortcut instead directly. It's 1 by f, 1 by u plus, right? Can I like multiply it? So u plus v by uv is equal to 1 by f, right? F is equal to uv by u plus v. Okay, this is the formula. Fine. So for image distance, so this is the formula of f. Okay, so this is a simplified formula. If we know the value, we can just apply it and directly put it, right? So V we have given minus 10. So V is minus 30 V. Okay. So U is minus 30. But if we need, sorry for this extreme confusion. If we need V, okay, if we need V, what would I do? 1 by F minus 1 by U is equal to 1 by V, right? So again multiply UF by U minus F by UF, okay, UF by U minus F if we reciprocal it, okay, fine. Now just put the values and get the answer, that's it. Now it's even easier, right? Minus 10 divided by minus 30 plus 10, right, which is 300 divided by minus 20, which is minus 15 centimeter. That's it, right? So real inverted, so just remember this formula. Okay, just remember. So similarly you can do for that also, right? So U is equal to minus 15. We need to find V, and we know that F is equal to minus 10 centimeter, fine. So what is the formula? UF by U minus F, right? So UF minus 15 minus 10 by U minus F, minus 15 plus 10, right? Minus minus gets cancelled, 150 divided by 25, 5, okay. What will you get? Minus 50, 30, minus 30, fine. Now we also need to find the magnification. HI by H0 is the magnification formula. So height of image, is it given? Height of image is not given, so we know that it is equal to minus V by U, right? See, we need to take the sign conventions, that's why minus V by U came, okay. Minus 15 by what is U? 30, minus 30, right? Minus 1 by 2, minus 1 by 2 is the answer. So I've got a magnification as minus, so can I tell that it is gonna be a real image, inverted image, small size, because if it's less than 1 itself, it's small size between F and C, fine. So similarly, how will you tell real? So here somehow if you do that, it will come minus 2, right? So it's going to be real, and inverted, it's greater than 1, right? See, minus, numerically it's greater than 1, right? So enlarged, fine. Okay, moving further. Okay, we need, let's do for the same question, but in this case we will convert into convex mirror. We will do for convex mirror. U is equal to minus 30 will be the same, because object distance is like not the direction of incident ray, fine. So F is equal to, not minus, in this case just for convex it will be positive, okay. So similarly we put the same formula. There is no formula difference for concave and convex. For both there is the same formula, which is minus 30, 10, minus 30 plus minus 10, right? Minus 40 minus 300 gets cancelled, it will come like 7.5, right? So hi by h naught, what is it? Minus v by u is equal to minus 7.5 by minus 30, 1.4. Fine. So this will be virtual, erect, small size, and it will be beyond p. Fine. It will be beyond p. Now let me give a table which will be very helpful for you in solving questions. Okay, this is concave, this is convex. When m is greater than 1 and positive, see here I've tell like beyond p, so here I've told like between f and c, right? So how did I tell that, right? That question may have come. So just remember this table. When m is like so much greater than 1, then this case will occur when object is between f and between pole and focus. Fine. So when m is greater, the object will be between f and p. Okay. So m is lesser than 1 and negative, object placed beyond c, beyond c. So m is equal to 1 and negative, object at c. So m is lesser than 1, sorry, m is greater than 1 and negative, this is positive, this is negative, when object between c and f. Okay, so m is greater than 1 and positive, m is lesser than 1 and positive, this is not possible in concave. Fine. So this case will come here, and the last case, which is not possible in concave, will come in convex, and that will be the only case in convex. M is positive and m greater than 1. Fine. Okay. Moving further, diameter of a image of a distant object. Diameter of image of a distant object. So what will you do for that? Let's say there is a concave mirror. Yeah. Let's say there's a sun, right? The rays will come like this, right? And it will be like this. Yeah. Theta, theta. Okay. So this is diameter of image. Okay. And we know this is f. Right. So don't force too much. It's a simple formula. Diameter of image is equal to f theta, focal length multiplied by the theta. Okay. Okay, is understood. Fine. Moving further, we have some couple of questions. Okay, we have some couple of questions. like you need to trace the path. Let's put a question. You need a light ray is passing at a degree theta is equal to 30 degree, okay, and the angle of this will be 60, and all the inside angle or reflecting thing. Now you need to draw the what light followed. So we know this is equal to 30 degree, yeah, vertically opposite angles. It doesn't bend in this case, so we take 30 degree, okay. So as it goes here, it reaches here, this will be 90 degree, so it comes back to the same position. This is normal incidence, so it comes back to the same position. Let's take case B. This is gonna be given as 60, okay. Wait, I think this case is not required, okay. Let's go for another topic, velocity in spherical mirror. We have seen velocity in plane mirror. Now we need to see velocity in spherical mirror. The same way here also we need to differentiate it, that's it, with respect to t. So first thing, when object moves along principal axis, right? When object moves along principal axis, okay, when object moves along principal axis, we know that 1 by f is equal to 1 by v plus 1 by u. Clear? It is the formula which relates the distance with respect to x-axis. This is the only formula, right? So I'm going to differentiate it. So I'll get something like 1 by v square dv by dt. We have already differentiated it in magnification question, du by dt. This will be velocity of image, this will be velocity of object. Do you agree with me? Okay. So manipulating it a bit. So velocity of image by, so let's convert it first so that no confusion occurs. Velocity of image minus 1 by u square velocity of object. Fine. Now let's put it here itself, okay. So velocity of image by v naught v square is equal to velocity of object by u square minus sign. Fine. Now let's simplify it further. Velocity of image is equal to minus v square by u square velocity of object. V by minus v by u is nothing but minus m square velocity of object with respect to mirror, velocity of image with respect to mirror. This will be the formula. Fine. Just remember the formula, that's more than enough. Okay, let's move to the second case. When object moves perpendicular to principal axis, Fine. Like this. So in this case, hi by h naught minus v by c. We need to use this formula only, because you need to check a formula in which the vertical distance changes. Okay, vertical distance changes, and which is related to the distance between the mirror. So in that case, this is the only formula which it relates. Okay, so do some simplifications and you will get something like, now differentiate dhi by dt is equal to minus v by u dh naught by dt. So this will be velocity of image is equal to mv naught. Fine. Clear? Okay, this is another formula when it is perpendicular to principal axis, not to the mirror, to the principal axis. So another last case, which is third case, which is at angle theta from the principal axis. This we have studied it in the mirror concepts itself. The velocities will be individually taken along the principal axis and perpendicular to the principal axis, and we will get to solve that, right? We have solved questions in previous things. Okay, moving further, next we will be seeing a topic called combination of mirror. So what is a combination of mirror? For example, this is mirror 1 and this is mirror 2. Fine. I'm going to place an object here, and how the ray will be looking like, it will go here, so it will go here, it will go somewhere like here, and it will go and join with this axis here, and here image will be formed. Let's say this is 20 centimeter and this is 30 centimeter. So this is an array diagram of this concept. Let's say we have a question with this associatedly. So what is the question is, find the location of final image of O after 2 reflection, assuming that the reflection is from mirror 1. So it's starting from mirror 1. Okay, reflection is from mirror 1. Fine. So it intersects here. Fine. We need to intersect in order to get image, right? So I'm going to put something, I'm going to incident a normal ray here, so that it retraces the same path and it goes till here and intersects and forms an image. Fine. So since we have asked us to find the location of image, final image, we know that u is equal to minus 30. Okay, this is the incident ray, right? So u is equal to minus 30, f is equal to minus 20. We need to find v. We know the formula is v is equal to uf by u minus f, which is 60 centimeter. It comes out to be 60 centimeter. And for second reflection, we know that u is equal to 10 centimeter. Sorry, u is equal to 10. So image will be formed somewhere here. Somewhere here, right? Since the image will be formed and this will be 10 centimeter, immediate here image 2 will be formed. I hope you understand. So u is equal to 10. Since mirror equidistant, then image also will be, v is also will be equal to 10. So why 10? Lot of people can ask, right? So we have got minus 60. Okay, this is minus 60, not plus 60. My bad. We have got minus 60, which means in this direction it's 60. We have 30, 20, which is 50 is covered. So it will be, image will be forming here, right? Of this object from this mirror, image will be forming 10 centimeter ahead of the plane mirror. So the plane mirror will again reflect and give its image here. Hope you understand. Moving further, let's see some graph. Okay, so just think it practically, you would understand the graph. I don't need to explain it a lot. It will look something like this. Okay, if they ask question in the graph, I think it will be of the same question, so don't worry. So it will be something like this only. They can't ask something other than this, right? But try to understand it practically so that you can analyze any graph when it is given at any type. This will be 2f, this will be f. I think it's not easily understandable, but listen. See, at this point you can see there is no intersection, which means it's forming an asymptote there. So why is it so? Because at f, so before getting there, this will be u and this will be v. Okay, and this part will be virtual image and this part will be real image and this part will be real object, this part will be virtual object. Virtual, real, virtual image, real image. Fine. Okay, now when virtual image is at 2f, where will be the, when the real image is at 2f, where will be the object will be placed? 2f is center, right? So it will be placed at the center only. Done. That's what it has been written here. See, I think like it is too complicated to understand. Just remember it, that is more than enough. Fine. So similarly, this is for concave. Now let me draw for convex. So it will be something like this. Just look at this point, that's more than enough. Okay, it will be something like this. Okay, this will be 2f, f. Fine. same thing. Okay, fine. Just understand the graph. This is for convex. Understanding the graph is more than enough in this types of graph problem. Okay, let's move into a really interesting concept, which is refraction. So refraction is a really interesting concept. So what is a refraction? It is a bending of light when it enters from one medium to another medium with different optical density. Let's say there is a water, fine, there is a water, and you are having a laser, and you are planning to put the laser inside the water, and how will it look? It will be bending, right? Okay, it will be bending. It will be bending like this or like this, fine. Sorry, not like this, something like this, fine. So this will be the normal, fine. So which case will you take? It will bend like this or this? Of course it will bend like this. Okay, when it goes from rarer to denser, it bends towards the normal. In opposite, if you are in water and then taking the laser outside, it will be like this, fine. So when denser to rarer, it will bend away from normal. So water is considered as a denser medium. Okay, let's go further. Next topic, refractive index. What is refractive index? So refractive index is denoted by the sign mu, fine, which is equal to C by V. So V is nothing but speed of light in medium. Speed of light in medium. And C is nothing but speed of light in vacuum, right? So this is a formula which you must know. And there is something called relative refractive index, which is denoted by mu12. Refractive index of 2 with respect to 1. With refractive index of 1 with respect to 2. Okay, we can also denote it like this, 1 with respect to 2. We can also denote it by like this also, right? Sorry, yeah, fine. And also understand an important relation, which is water with respect to gas. Gas with respect to water, fine. Okay, did I write? Oh, sorry. Okay, no, gas with, see, 2 with respect to 1. If I would have said wrong, that's incorrect. Please change it. You need to call it as 2 with respect to 1. Okay, fine. Now it will be directly proportional to velocity of water, inversely proportional to the velocity of water, velocity of gas. Wavelength Since velocity and wavelength are directly proportional, you can write it as such. So how does this work? Let's say water's there, and you're gonna pitch the light here. Fine. Don't you think the water will slow down? Sorry, the speed of light will slow down after reaching the surface of the water, or do you think the light will continue with increased speed? No, right? The velocity will be slowed down when water is with high density, right? Than the air. Of course it is. So mu will be inversely proportional to V. Mu of gas will be inversely proportional to the V of gas, right? And V is directly proportional to lambda. Fine. So you would have studied an effect called a dispersion effect. In prism, you will disperse light and it will go like this, right? And this will be red light and this will be violet light. So that comes from some mnemonics which is called VIBGYOR. Okay, violet, indigo, blue, green, yellow, orange, red. Right. Red will have the maximum wavelength, so I can write red will have the maximum wavelength than velocity. How do you find whether V or red, violet or red, will have the maximum what? Maximum refractive index. So it is inversely proportional, as I said, right? So violet will have more refractive index than red. Fine. Now let's go for some laws of reflection. Laws of refraction. So similar to that law of reflection, normal, incident, all in the same plane. Here also there is something similar, which is incident ray, refracted ray, normal, all lies in same plane. Incident ray, refracted ray, normal, all lie in same plane. Okay. Second law is Snell's law. U sin I, U1 sin I is equal to U2 sin R. Okay. For example, it's going like this, right? And this is normal, incident, refracted, mu1, mu2, right? We don't say this is refracted and incident, we tell this is emergence and this is refracted. Fine. And this is I and this is R. If you said this is R, it's absolutely wrong statement, because we have studied before, every angle is measured from the normal, so this will be R. Fine. Good. Now what's the relation? So the refractive index where I is there, you call it as mu1. This is a trick, okay? Then refractive index where R is there, you call it as mu2. That's it, simple. Okay, mu1 sin I is equal to mu2 sin R. Okay, with this you can, if they asked you to find this, you can find. If they ask you to find this, you can find. This is a general max, I no need to explain this, right? Yeah. Further, I'll give a question. Try to do it by yourself. If the wavelength of light is 4800 Armstrong, then find the wavelength of which has refractive index. This is diamond, okay? Diamond. And it has refractive index mu is equal to 2.4. Fine. So the wavelength is given. So How can I tell? So refractive index of air, wavelength of air. So wavelength of air is given as 4800 Armstrong, right? And refractive index is given. So diamond by air is equal to 4800 by diamond, right? Okay, we know this is 2.4. okay, and mu of air is 1, so mu d will be 48 sorry lambda d will be 2.4, which will be approximately equal to 24 by 10 goes there, and 2000, I guess. Yeah, if I'm not wrong, it's 2000 Armstrong. Fine. See, whenever there is a ratio like this, if you wanted to calculate the ratio, you can use this thing, which is inversely proportional concept. Lambda is inversely proportional to mu, right? So you can use this concept. But if you have this and if you want to apply and get the answer, this formula won't work. Okay, only for ratio calculation you can use this concept. Understood? Clear? Moving further. So angle of deviation. So angle of deviation, I think the formula is itself more enough. So let's say it's denser medium, this is a rarer medium, and it goes like this, fine, away from normal, it goes away from normal. We know this is refracted ray and this is incident ray. Okay, let me draw it clearly. This is a medium barrier. Okay, let me draw the normal first, and let me draw the ray. Fine. If it was undeviated, it will go like this, right? So this will be delta. Fine. So delta will be equal to r minus I mod, where r is refracted angle and I is emergence angle. Fine. Okay, now just remember the formula. This is a formula. Okay, now let's go for in a glass slab. Let's analyze this glass slab concept. Fine. Let's see. Fine. This is mu of medium, mu 1, mu 2, mu 3, and mu medium again. Okay, so this goes like this, and given that mu 1 is greater than mu 2 and mu 2 is greater than mu 3, right? So I'm going to incident an angle, light ray, right? So since mu 1 is greater than mu m as well, so I can write it's gonna go near this, and given that mu 1 is greater than mu 2, which means it's going from denser to rarer, which means it's going away from the normal, right? So similarly it's going away from the normal. At last it will go like this. Okay, and if you observe nicely, like if you observe closely, angle of incidence will be equal to the angle of emergence at last. Okay, only when light rays goes and comes back to the same medium, angle of incidence is equal to angle of refraction. If it is medium 2, it won't be won't be equal to r. Okay, fine. Moving further we will be seeing two concepts, which is called lateral shift and total deviation. So let us see what is lateral shift first. Okay, we incident on a glass slab. Okay, we know it goes like this, and here it comes like this. Fine, but if it has same medium, the light ray will somehow go like this, right? So this distance between the undeviated light ray and the deviated light ray will be called as delta, and that will be known as the lateral shift, and that can be calculated by t sine theta I minus r by cos r. Formula, remember it. Fine. Okay, so similarly, if there is a bunch of glass slabs and you want to incident a ray like this, okay, it goes, it comes like this. Fine. So if it is undeviated, yeah, all these are delta. Fine, I hope you understand that. See, the same case, if you rotate by 90 degree, this case will come. How many of you agree this? Yes, right? So I can write the total delta is equal to delta 1 plus delta 2 plus delta 3. Fine. So same, add this 3 times. Delta is equal to T1. This is thickness. In this case, what we have taken? This thickness, right? So similarly in this case we will take this thickness. Fine. We take T1 sine I minus r by cos r1 plus T2 sine I minus r by cos r2 plus T3 sine I minus r3 r2 r1 cos r3. Fine. So this will be the formula, which in this case, if you want to calculate it, you can. Fine. So there are some cases when light do not bend. Cases where light do not bend. Fine. So what are those cases? Let's say this is a normal and this is the slab. Fine. If the light ray is like this, for a light ray to be like this, mu1 should be equal to mu2. In that case only light ray doesn't bend. Fine. Or there can be another case also. In case of normal incidence, you want to incident perpendicularly, in that case also light ray doesn't bend. Fine. And in case of grazing incidents, light ray will bend. Okay, it will be something like this. Okay, this will be I, this will be R. Okay, so I think this is enough for lecture 2. And the next lecture we will be seeing real depth and apparent depth concepts. Fine, and shortcuts for those. And probably we will be seeing prism and concave lens.